Yes, I think screen is visible to you, right?
Yes, it's very visible.
Yeah,
Yes,
maybe
doctor.
you can have a biro and a paper so that you can note down. Some mathematics will come. I don't know if you are aware. This machine learning, if you are very strong in mathematics, you can contribute a lot. If you are not strong in mathematics, it will create a problem. So it is mix of theory and mathematics, right? Yeah. So although concepts are there, but mathematical inclination of the algorithm is on high side. Hmm. So everywhere you will see that they will talk about mathematics while developing the things. And machine learning programmers generally, if they don't know the programming and they don't know the mathematics, things are like limited. Mathematics, especially the part which is being used, is statistical part and a little bit arithmetic, but mostly we are using statistical part of the mathematics, right? So,
Yes.
class, this is the topic, second topic. Of course, we can say that if you remember, first topic was in KDD, knowledge in database. What was the topic? First one, you have to start with data pre-processing, then data transformation before going to machine learning others, right? So this data pre-processing is very very important part of the machine learning. So data pre-processing include basically data transformations, data cleaning, and some other parts are also there like feature selection. So many techniques are there in the pre-processing steps, right? So what is purpose here? The purpose of preparation is to transform data sets so that their information content is best exposed to the mining tools. Mining tool here, they are talking about data mining are just like extracting tools or machine learning tool. Error prediction rates should be lower or the same after the preparation as before it was. So this is the purpose actually. What is purpose of data pre-processing? That given a data set, question is that how to transform the data sets into another form so that the information is content is best exposed to the mining tool, right? Yeah. Clear, class? Your data may be noisy. I told you, yeah, on the previous class, noise data means how. What do you mean by noisy data? Means like inconsistency, and sometime some fields may be missing, right? Some fields may be missing, right? Like pocket money, some columns it is not given there. So if you are not processing it, it will not give you the good result. Clear, class? Is it clear?
Yes, Prof.
So that is the purpose of the pre-processing. So sometime in machine learning, if you are very good in pre-processing the algorithms, you at least you can contribute even from the data pre-processing. Research will start from the pre-processing itself. And this has another purpose. You might have been hearing about outlier. Outlier is the term like data set is not like within the content, it is outside your domain. Like see here, suppose there is one cluster of the data set having 1000, another cluster is 1000. So this is something like less than, let's say, close to 50 or 100, and this is very far from the thing. So that means this will be treated as an outlier. Let me explain. An outlier will also be detected during data pre-processing. Since this kind of data is not important, so it's better to remove them. Like see here, suppose I'm talking about this is x-axis, this is y-axis. Suppose I'm talking about this, class. Suppose I'm talking about this. This is the data set, and this is one data set here. This is one data set, and there are plenty of here. Can you tell me, they are here in this data set? What about this? Are they not outside of the domain, class? Hello?
The outside.
So you know, they are outlier actually. They are outlier, and such kind of data sets are going to be removed during the pre-processing. So this is not within the data range. So that means you have to remove this during pre-processing. Clear? Clear to everybody?
Yes.
Okay. So yeah. So why data pre-processing? Let's see. Data need to be formatted for a given software tool. Yeah, because you will see that if your data set is wrong, you will sometime while running the machine learning algorithm, you will see the 100% accuracy. And you know that if 100% accuracy is coming, that means it is not desirable. It is wrong accuracy, right? Yeah, it's not correct. So these kind of things are not going to be decided. So data need to be formatted for a given software tool. Data need to be made adequate for a given method. Data in the real world is dirty. Dirty means that it is not correct. So many noises are there. Like see, incomplete, how to understand? Like see, lacking attribute value, lacking certain attribute of interest. For example, occupation is not given. It is just like empty. But you need to fill it so that you can get the value. Noisy, containing error or outlier, like salary is -10. Is it not noisy? Nobody can earn a negative salary, right? At least everybody can get some positive salary. So these kind of things are noisy data set. So this is coming under noise. Age is 222. Oh God, age cannot be 222. So this is also one of the noise. Inconsistent. Suppose your date of birth is 42 and birthday is something. This, if you correlate birthday and date of birth, you will see that this is wrong. So this kind of data set, it only can be detected during pre-processing. Otherwise, if you are not pre-processing properly, it will be another problem. Another thing is like stop word removal, and here, sometimes there are many stop word in the language, so in the text, so it need to be removed. Comma removal, semicolon, this kind of things should be removed for before the uh, machine learning algorithm is applied, right? Yeah. So class, see this KDD, data cleaning integration. We are here. We are here. Data cleaning and integration. We are not here. We will come here. Then data mining, or you see here, machine learning will be here. This is the here. And then evaluation presentation. This is the basic step in KDD. So that means we are still here. We need to understand data cleaning mechanism and integrated. Do you know the meaning of integration, class? Do you know the meaning of data integration? Anyone? What do you mean by data integration? Class? Dr.
I think
Mhm.
I think it's bringing data into maybe an existing system to be used for decision making. So in
Integration.
such a way, the data
Integration.
must.
Data integration. Do you know means integration means?
Could it be data breakdown? Have data been breaking down into simpler form?
Okay, let me hear Dr. Roj. Aliyu. Dr. Rose, are you there? Nonso. Class rep, are you there? Lucy.
I'm here, doctor.
Yes,
I
yes.
was thinking maybe the breaking down of data to its simpler form. Could it be it? I'm not sure.
No, let me.
Or is it combining data?
That is it, simple. You see, data integration is very, very simple concept, right? You know, you may be getting data in audio format, you may be getting data in text format, you may be getting data in image format. But you know, integration here means that you are bringing all this data together. Like, you know, your algorithm can process only text. So in that situation, you have to integrate entire data set to make it text data set. Are you getting my point?
Yes, yes, sir.
You know, sometime like you know, you may not be getting text data set, especially like disease data set. Sometime you, what you are getting x-rays of the images, right? From the x-ray you are extracting the information. If you see that, sometime, you know, you might have seen the x-ray report. If you go to x-ray report, if your algorithm, suppose you are not using algorithm which is processing the images, then what you will do, and your data set is image. So in that situation, you have to extract, convert that data images into the form of text, right? This is always happening, that unstructured data set used to be converted into structured data set, right? So structured data set in the form of the table. Suppose you see, if you go to this like X-ray, they are writing description in the down. Not like you can read from X-ray. X-ray you can read only if your machine learning algorithm is reading the images, right? Otherwise, you cannot read it. So what will happen, class? You know, you have to convert that X-ray description into the text. So you need to go into the description, not an image. Or from the description image itself, you have to bring down the text, and so that your algorithm can understand the text. So this integration from text to image, image to text, audio, video, all this data set need to be bring together so that your algorithm can proceed. So this is also happening into the, okay. You might have seen that this information retrieval. Have you heard about this terminology, information retrieval? Anybody? Class, have you heard about information retrieval and page ranking? Anyone has heard about in information retrieval and page ranking? Page ranking.
Me too.
Yes,
Uh,
I've heard of information retrieval.
Yeah, information retrieval. Yes.
Page ranking. You don't know Google's page ranking?
Right.
Plus, you know, if you are writing something, searching something on Google, suppose you prepare your own website, and you know, if you are not like providing heating, it will not come up. So they will write you, they will search your like website or your product on Google. It will not come up until you apply your own
Yes,
page ranking method, so that your pages can be ranked higher than others. So it will come up.
yes.
Aha, you see this. This is one of the target in digital marketing. Let me see this. Let me show you. 1 minute. You know, this is very important to understand this page ranking mechanism. See this Google. This is Google, right? Yeah. Yeah. Let me 1 minute. Yeah. So I'm searching here Google, on Google. See this African University, our own this is African University, Africa University, University in Zimbabwe, Nigeria. Me, I'm just writing down here. See this. Our own is like using very good page ranking. This will come. African University of Science and Technology. It will come. Same thing. You see, all this thing is coming. Top universities. You know, this depend on the page ranking. It will come up. It will come up. Right? Yeah. Like University of Abuja. African University in Nigeria, African University, Nigeria, or just write down University Nigeria. All they will come only if they have been designed with good page ranking. Are you getting my point, class?
Yes,
Hello?
doctor. Yes, yes, we are
Yes,
getting it, sir.
yes.
See, this top 9 universities are coming and your university is not here. In first one, your
I
top,
can see.
yeah, you see this is
Yes.
not coming because maybe is not using very good page ranking, so it is not coming up because general person is just writing University Nigeria, right? So you know most of them they are coming. You see National University of Lagos and University of Abuja. I don't know how they have which page ranking they have done it, but it is not even coming in top page ranking algorithm. So you know this thing situation is something that you know information retrieval is only using the page ranking. So it's not like Google is going to provide you. No, you have to one. You are the one who is providing your own page ranking mechanism so that it can achieve higher hit and it can come up. See in University Nigeria Abuja, you know sometime you have to be very very specific. Even still it is not coming, although University of
Is
Abuja should come. Are you
is
getting
there
my
is a,
point?
is the number one is there?
Is number one now, right?
Up there.
Yeah.
Yes.
So you know you are going very very specific University Nigeria Abuja, then it is coming. So it's like not like something, it will come. Problem is that uh, it is just page ranking, something mechanism. It will come. Is like this is the method which we call it uh, information retrieval. Okay, I'm coming. So class, so this is how we have to do it. Okay, so let's go to the next topic. So this information retrieval, page ranking, all these things they are going to be integrated together with machine learning. Now you know people are doing hybridized research from one dimension to another dimension, right? Yeah. So types of data and measurement. Let's talk about types of data. Nominal scale. Generally, we are preferring five types of data: nominal scale, categorical scale, ordinal scale, interval scale, and ratio scale. Right? So nominal scale, categorical scale, and ordinal scale, qualitative in nature. Yeah, right. And interval and the ratio scale they are quantitative in nature. So as so you are migrating from qualitative to quantitative, more information content you are gaining more information content, right? Look at here. So qualitative then quantitative, nominal, categorical, ordinal. See this class. Nominal scale, ID number, name of people. So this is an example of nominal scale, right? It's just like is qualitative in nature. Categorical scale, like you can categorize eye color, blood groups, right? They will be classified as categorical group, like 1 or 2 category, 3 category, 4 category, right? So they will be treated as categorical group. Ordinal scale is a ranking, right? Like see height in tall, medium, short, or ranking. Let's say from 1 to 100 or 1 to 10. Grades. Grades will be like your number. Marks will be like you see. If you are getting like 0 to 49, you are getting which grade? C, right? Sorry. You know, like no. If you are getting less than 50, and 50, like less than 50 you are getting fail. 50 to 60, 60, 50 to 60 60 you are getting C grade. So this is actually ordinal scale, it's not categorical scale. Is categorical is like categories, right? Male female. So male female will not come under nominal, male female will be coming under categorical scale. Clear class?
Yes, Prof.
Yes, sir.
Yes, sir.
Ordinal scale is just like a number, numerical, like see, you are getting like 70 plus, you are getting which grade? You are getting A grade. So this is coming under the ordinal scale. Interval scales, like there is something interval like GRE and IQ score. They are like more of them, More of them, they are quantitative in nature. And then ratio is scale, temperature in Kelvin, length, time. All of them, they are continuous variable and quantitative. Ratio scales, they are always in quantitative. So this kind of data you are going to deal with. Generally id, number, name of something is always coming under nominal. Categorical scale, category is male female, like let's say blood group, or some category like rich poor, or like car, luxury, sports, and any kind of car. Almost they are coming under categorical. Ordinal, if you are just comparing, then it will come ordinal. And if you have some like interval values that between this to this, like seen is like percentile will be coming under interval scale. Ratio scale is like, yes, Aliyu, go ahead.
Go ahead.
Good evening, Prof.
Good evening, Aliyu, go ahead.
I have a little bit of a network challenge. That is why.
You want to ask question, Aliyu? Aliyu, you want to ask a question? Aliyu, you raised your hand. Do you have some question?
Doc, I think he's having network challenge at the moment.
No, I'm asking, do you have some question in mind?
Put on the group chat for him. I don't think he's hearing you.
So I'm saying that Aliyu, he's raising his hand. Okay, no problem. If he has question, he will ask. Okay. So class, this is the type of data and measurement. Mostly you will be dealing with categorical or like this ratio scale data. So class, this is data conversion. You remember data conversion, data transformation. There are differences between them. Transforming from one form to another. It's just like data conversion from one form to another with equivalent comparison, reversible in the nature. Data transformation sometimes is not reversible in nature, but data conversion is reversible in nature. Look at here. Suppose you have A grade, number is 4.0, and like in your public university system, A grade number is 5.0. Am I right, class?
Yes, sir.
Yes.
And then your B grade is 4.0. So you know if it is equally reversible, B 5 to A and A to 5, it is equally reversible. In our own system, this is the grading style, right? And in public university system, A is 5, B is 4, and C is I think 3.0, if I'm not wrong. This is your own system, right?
Yes.
Yeah, so this is data conversion. Why we need it? Sometime our algorithm is not understanding these numbers, right? This later. So if it is not understanding later and it is understanding only number, you should go ahead with number, not with the later. Very simple, right? Okay. So let's talk about major tasks in data preparation. These are the major tasks in data preparation. We will be talking about data discretization, part of data reduction, but with particular importance, especially for numerical data. Then second data preparation task is data cleaning, fill in missing values, smooth noisy data, identify or remove outliers, and resolve inconsistencies. So this is coming under data cleaning. Data discretization is converting data from like continuous variable to the discrete variable. Then next is data integration, which is integration of multiple databases, data cubes or files, right? Yeah. So this is a data integration. And I hope it is clear. Integration of multiple databases, right? You are integrating multiple databases to bring into one database, and then data cubes and or files, right? Yeah. And next is data reduction and transformation. And generally in data reduction and transformation, we'll talk about normalization, aggregation, sampling, principal component analysis, singular value decomposition, latent semantic analysis, and dimensionality reduction. You know, this is my favorite topic, and I like this topic most. Why I like this topic most? There is reason behind that. If you are going to do research in machine learning, what will happen? Those who have already done some research in machine learning, I know that since you are already doing PhDs, you must be having some exposure on machine learning, or you must be having some exposure on research, right? So because this course objective is to just expose you with the with the concept of research also. It's not like just to teach and forget. Ali, you go ahead. Ali, you are raising your hand. Can you ask the question? Class captain, can you help him? Class captain, are you there?
Yes, I've tried to talk to him in the platform. Let me try again. I think he's having a network issue, sir.
But he is raising his hand again and again. So,
Yes, I told
I'm
him
calling
to. If
him.
he's not questioning,
Ali, do you have any question? Prof is asking if you have question. Okay, Prof, he said it's a mistake.
okay.
Prof, he said it's a mistake, please.
Okay,
Yeah,
okay,
go
no
ahead.
problem. Yeah. So what I was talking about, like this machine learning is more or less is not a coursework, right? It's just like learning from the scratch also, that how much you want to learn about this course. Because objective of bringing this course in PhD is that you must be doing some hands-on also, so that you should know the ABCD of machine learning. And once you know the ABCD of machine learning, at least you can upgrade yourself. So anyone has a little bit idea of the machine learning research? Roj, do you have anyone is having little bit idea?
Not for now. I don't have the idea.
But Dr. Rose may be having.
Prof, I'm hearing, sir.
Do you have little bit idea on machine learning research?
Not too well yet.
But you have heard about something about machine learning. Everywhere it is going, AI, machine learning, data
Yes, yes.
science. So people are running here and there for this against, like after this machine learning. So definitely you may be aware, right?
Yes, yes.
Lucy, do you have little bit idea?
Yes, doctor, very little idea.
Okay. So no problem. We'll be having more idea. Definitely, we'll be doing some practical aspect of the machine learning, not only theoretical aspect. From the next class, we'll be doing.
All right, sir.
Yeah, we'll be doing some hands-on together with this like theory. Yeah, it's not a big deal. But
All right, sir.
yes. So you see this, what is happening in machine learning research? machine learning research, you will enter into it, you will see most of the packages are already there in Python, or R or MATLAB. So what is your objective is to just customize them, right? So since packages are there, you need to customize them. So customization, how it will be done, the customization. So like see, classification tasks, they are implemented already in Python. So you need to import your own data set, change your own data set and customize the code with reference to your own concept, right? And you will get the answer. That means you are not going to implement the classification or clustering any task, right? So but then problem is that where is the novelty, what you are bringing, what is novel in your work, how it is new. So new things is always coming to handle the data set. Sometimes you can handle the data set differently. If you can handle your data set differently, which can improve the accuracy of your system, that is much better. It will improve your work, right? Are you getting my point?
Yes, yes,
So,
doctor.
so this
Yes.
dimensionality reduction will be one of the part. You have many dimensions. Dimensions, let me tell you dimensions. Like your data set will be in the form of tables, right? Like see, many columns your data set will be having. Sometime 100 columns. Plenty of the columns are there, right? Plenty. So you know you cannot handle all the columns, especially if they are not relevant, right? So if they are not relevant, what will happen? If they are not relevant, so you need to reduce them. You need to remove some columns or you need to transform this entire data set to another form. So this dimensionality reduction is very, very good technique, right? You know this dimensionality reduction is a good technique which is just reducing the dimension of the data set. So this is what we are going to talk about, right? Yeah. So it's very, very, so many algorithms are there, and but mostly algorithms are already there. So, you know, one of the popular algorithm is principal component analysis. Yeah, you will see that this is very important algorithm of dimensionality reduction, right? Yeah. So next one is correlation. Correlation and regression. They are two important tasks in this machine learning. You might have heard about correlation also. You might have heard about regression also. So Dr. Rose, can you explain little bit about correlation? Have you heard about correlation? Dr. Rose, can you hear me? No.
Hello, sir.
Yes, yes. So have you done research something on correlation?
Yeah, I think majorly, I think it has to do with relationship between two or
Two
more
variables.
variables. Yes, sir.
So what is its physical significance, doctor?
Sir,
What is its physical significance?
the significance. Say it again,
Physical
sir.
significance, yeah.
Between two variables.
Mm-hmm.
Uh, Basically, it has to do with the ability to get the interdependencies.
No, no. So me, I'm asking.
Yes,
So
sir.
okay, so yeah. So can if suppose two variables are not correlated, what will happen?
Oh,
So are you going to consider both of them if they are not correlated?
Uh, not necessarily.
Not necessary. That is what I wanted to know. Like, see, suppose you are working on predicting the heart disease, right? You know,
Yes.
heart disease, if it is having no like relationship with your something status, like whether you are rich or whether you are poor. So, are you going to consider that parameter, that dimension in your study?
No, not necessarily, Prof.
Not necessary. But if you are working on heart disease, right? So
Yes.
this heart disease, are you not going to consider the, and suppose you have weight, major weight, definitely everybody know that heart disease, if you have like weight, you are gaining the weight day by day, you may have chance of getting heart disease, right?
That's right. That's right.
Same thing sometime if you are having excess BP, blood
Yeah.
pressure is very, very high, heart disease is affected. That means these variables have correlation with the heart disease.
Yes.
So this correlation, is important task in machine learning. You just like we can use Carl Person or some other correlations, but if two variables are not correlated, generally we use to discard them. Suppose this y, which is function of many parameters, right? And if
Yeah.
this is not function of like any attribute, is why to consider that attribute, means this is not depending on a particular attribute. It's better not to consider this y. Clear?
That's right. Yes.
Okay? Yeah.
Yes.
So
Yes, sir.
correlation regression is one of the tasks. Let's talk about discretization of a continuous variable. Why we use discretization, data discretization, to gain insight of a particular data set. Class, why to use data discretization? To gain insight, to know the nature of the data set. Because once data set is continuous, you may not know the exact category of the data set. So this discretization is the process of converting continuous variable to the discrete variable so that you can gain insight of the data set, right? So what is happening? Divide the range of a continuous attribute into intervals. Aliyu, you are coming and always raising hand. Okay.
So you can continue. I think that's the first mistake. Maybe he didn't know how to remove it. Thank you, sir.
Okay, no problem. So maybe I know I can lower down his hands. He's not necessary, not like something. I can lower down his hand. Yeah.
Yes, sir.
From my
Can you
side,
control it from there? Can lower down.
I can lower down his hand.
Yes, sir. Just lower it. I think it's a mistake.
Okay, it's mistake, right? So no problem. Let me continue. Yeah. So class, so discretization is first step of converting continuous variable to the discrete variable, right? Yeah. So what will happen? Divide the range of a continuous attribute into intervals, right? Yeah. So some method requires discrete values. Why we need it? Because some method require discrete values to handle. Like, see, you will see that naive Bayes algorithm will require discrete values to handle. Reduce data set by discretization. Prepare for further analysis. This has major advantage. Many places we are going to use. So discretization is very useful for generating a summary of data. We call it binning, right? Yeah. This binning is important task in generating summary of a data. So data discretization first is equal width binning, right? Equal width binning. Yeah. So, and this is up to type, equal width and equal depth. So let's understand it. It is just like numerical question. There are two methods for data discretization, right? First is equal width EW, and second will be equal depth. This is just discretizing your data, converting from continuous to discrete. So it divides the range into n intervals of equal size, uniform grid, right? Yeah. So what will happen? Suppose A and B are the lowest and highest values of the attribute. The width of interval will be B minus A divided by N. So what will happen? W will be B minus B is highest value and A is lowest value divided by number of interval. N is N interval, and this interval you need to choose yourself. For example, temperature value. Arrange them into increasing order. Arrange the temperature into increasing order. So W will be BB 85 minus 64. B minus A divide by N interval. Let's say we have 7 interval total. We want to divide into 7 interval. Generally you see this is 21. So we decided that if you are dividing into 7, it will be giving you 3 equal interval. Otherwise 21 by, let's say, 7, 3, and then what is the next interval, so that you can get exact value, right? Yeah. So 21 like 9, if you give 9 not 9, it will not give you any value. What is the next interval which can give you actual value, class? If you are giving 3, you will get 7 value. If you are giving 3 interval, you will get 7, and then 7 like, then you will get 3. So these are the one which we are choosing accordingly. Okay, so we have 7 interval, it will be given to you, and then width will be 7. Okay, so class, this is your 64, 65, 68. This is closed interval, and then 64 to 67. What is its width? Its width is 3, right? Its width is 3. Look at here, 3. So you choose in such a way that 67 minus 64. So this will become 3. Its depth is 3, width is 3. How many in that? 64 to 67. Remember, we are not touching 67, it is open. So 64 to 66, 64, 65, only 2 of them are there. So this is 2. Clear, class? Clear to everybody?
Yes.
Yes, sir.
You
Yes,
know,
sir.
this is open and this is closed, so that 67 is not counted twice, right? So now 64, its width is 3, so 64 to 7, 67 to 70. So let's say 67 to 70, 67 to 70, 70 is not included, so it is still
We
2.
have 2. Yes.
Yes. So it's very simple. Now 70 to 73. Can you count it, class?
All right. 1, 2, 3,
4.
4. 4.
4.
Very good. It's correct.
It's 4.
Yes, sir.
73 include you to 76.
We have 2.
Okay.
Yes, 2.
Okay.
That's correct.
It's correct.
Yes,
sir.
doctor.
Very good. Very good. What of 76 to 79?
76.
No
No
value.
value there.
No. 0, right?
Yes, sir.
0.
Yes.
It
Okay.
is 0.
Very correct. 79 to 82.
79 to 82.
Remember, you are not
Two.
covering 82, 79
It's two,
to
it's two.
81.
It's 2. We have 80 and 81.
2.
Very good. 2, right? So 82 to 84. 2, right?
2, yes, sir.
Yes.
Can you check, class, whether all the data sets are covered? 2 plus 2, 4 plus 4, 6 plus 4 plus 4, 8 plus 2, 10 plus 4, 14. Is it not 14? 2, 2, 4, 2, 6, 2, 8, 2, 10, 4, 14, right?
Yes.
Yes, sir.
Okay.
14.
14. Me, I'm asking here. What you are concluding from this picture? Tell me what you are concluding from this picture.
So in terms of what, sir?
I can
It is
see
given to you.
that the interval, there's more occurrence of data between 70 to 73 and the less occurrence of data within 76 and 79.
Very correct. And is there any outlier? Is there any gap in the data set?
I can say that between 70 to 73, we have an outlier.
Yeah, this is
Or
this 76 to 79 is outlier, right?
It's the
Yes.
outlier, yes.
There is no there is gap over here.
Yes, yes, sir.
Serious gap over here. 1 minute, class. This boy, I don't know who is this. Is disturbing. Who is this person? I don't understand. From your class. Who is this? I don't know. 1 minute. Can you hold on? Let me call him. He's just keeping messaging to me. He's from Uni Abuja.
Sorry, sir.
Okay, sir, no problem.
It is HOD who has changed the course. So I think HOD will be in the best position to tell you that this is the course which you are going to take in this semester.
Yes, she told us.
So, are you referring to us, sir?
No.
Okay.
Okay. That's all. Thank you.
Okay, this is a student from Uni Abuja. MSc student. So okay, sorry class. So okay, so let's continue here. So you see this, there is a serious gap in this data set, right? Like there is no data range between 76 to 79, but the data set, most of them, they are lying from 70 to 73. So if somebody is saying the characteristic of the data set, you can easily explain them, right? Class.
Yes, sir.
Yes, sir.
Yeah. So
Yeah.
what is disadvantage? This is unsupervised. Question is that we don't know. Only like unsupervised means that from the data set itself, you are going to conclude that yes, this is the situation. Unsupervised means that okay, this is the one which is coming out. From the unsupervised, from the data itself, you are bringing out the information. Second problem is that where does n come from? This n, how to bring it, how to know what is the value of n, right? This n is the problem. This n is the problem. This n. Actually, this n is the issue, right? So, question is that where does n come from? Then second next is sensitive to outliers. See this. This is sensitive to outliers. What is advantage? This is simple and easy to implement. Produce a reasonable abstraction of the data. It is just giving you that how your data looks like, right? Clear class?
Yes,
Yes,
sir.
Prof.
Very
Yes,
simple.
sir.
Very simple
Yes.
data discretization. Equal width winning. Winning is just like very simple. Problem you have seen it already. Pros and cons you have seen it already. That yes, this is the problem and this is this demerit merits you have seen it. Okay. So let's talk about second one. Data discretization equal depth. Depth or height, right? First one was equal width and second one is equal depth. So it divides the range into n intervals, each containing approximately the same number of samples. This is generally preferred. Equal depth is preferred. We prefer this. In practice, almost equal height binning is used to give more intuitive breakpoints. Look at here. Let's talk about equal height 4. And this is your data set, right? Equal height 4. So definitely if you want to achieve 4 heights, so you know you are going to take 64 to 69. Clear class? Hello?
Yes, sir.
The
Yes,
next
sir.
4 is 70. You are finishing by 69. So 70 to 72 is the next 4. And then 73, don't go on 75, it is a continuous. You remember these intervals are continuous. You are finishing 69, then 70, 73, then you are taking from 70 to 72, then 73 to 73 to 81, right? Yeah, then 73 to 81. Okay, then next is 82 to 85. Last
85.
one you can easily, yeah, last one is exempted actually class, right? Except
Yes.
for the last bill. So can I give you 5 minute time to do the data discretization of this question by EW and ED? Class, do you want to do it now? Just try. And,
Okay.
Okay.
yeah, note down the question. It is very simple exercise.
Doc, can you display the values once more? Thank you, sir.
Let me know once you are done, yeah.
I tried something.
Are you
Yes,
done?
sir.
Are you done?
With what I have tried, yes, sir. Yes.
Okay, good. So, okay, so is there any confusion? Is there any doubt, or I should do it for just checking?
Yes, sir. Where I have confusion is in EW to get that
I'm
N.
still on it.
You have confusion on EW?
Yes, to get the N.
Yes, that is the confusion, but you should not worry about that. What you should do, arrange this data into increasing order, right? Okay, so once you arrange it, what is highest? Tell me. Highest is 45, right? And lowest is 13. So
Yes,
13.
lowest is 13.
yeah,
Lowest is 13, and the
yeah,
highest is
13.
45.
So 5 minus 3 is 2, 4 minus 1 is 3, right? 32. Are you getting my point, class? Hello.
Yes, doc.
So
Yes,
it's
doc.
better
Yes,
that
sir.
you can take 8 intervals. So that you know, if you can take n equal to 8, it will exactly be 4, right? You see this 8, at least you should get this as a whole number. Just like you see, we took 7, so you are just increasing into 3 widths, right? So your width should be small, so you just take them like 8, so it will be 4. How much you have taken this value?
4.
4.
Yes.
If you are taking 4 now, what will happen? If you are taking 4, 34 by 4, you know width will be very much. It will cover you 8 values, right? So it is very heavy width. So your width should be
No,
small,
it's
right?
just
So,
7 values.
huh?
7.
Yes, it will be covering 7 values, right? So you see here you are already having how many points? You know, you have like 3, 3, 6, 7. 3, you know, you will be covering 7. So your this frequency
7
table will be very
intervals.
small value. So you may not get this desired data set. So what should be the case? Your n should not be like this value. This interval should not be very big. Like see, this 8 is not desirable. Are you getting my point? You should keep low so that at least you should get the pattern of the data set. Clear?
Yes.
Class.
Yes, doc. Yes.
So 8 was very relevant. You know, after 4 you can only get 8 to get the exact answer, right? Otherwise you have to approximate it. So then after 8 you have to get 16. So two intervals is not appropriate. So appropriate, using appropriate is like this. That is the what things was written here. If you remember, it is written here. Where does n come from? This is the problem, right? This n is the issue. Clear? So you have to be very yes.
So, doctor, where did you get the N? That was my confusion.
Look at here what you did. N is like that is the problem here. But you know why I'm choosing n as yet 8, so that your interval should be 4. If you are making like a very big interval, like 4 interval is okay. At least you can divide your entire data set into number of interval. But if you are taking n equal to 4, your interval is 8. So all of them, they will be coming in only 2 intervals, right?
Yes.
So that's why you know
Yes, sir.
n should be in such a way that you can get equal some discretization of the data set. Otherwise, if you are dividing entire data set only in one interval, you are not going to gain anything. You see, had it been, it is like 8, it is 4 now. If you are choosing 4, it will be like 8 intervals. So
8.
it's
Yes, sir.
like, yeah, 8 means, you know that 8 number, 7 number will come and join here, right? So, you know, this 7 number will come here. It's like only you are having 3 intervals, right?
Yes, sir.
So this is not like appropriate, but you know, software is already choosing automatically and from themselves. So it's not a problem. If somebody can take n equal to 8, somebody can take n equal to 4. But if you are taking 4, look at your data set. Had it been, it is having million of the data set. Then you can choose n as 4 also. You can choose n equal to 16 also. It's not a problem. It's not a problem, right? Okay, class?
Yes, yes, sir.
Yes, because I counted them, they are equals to 16. So I did 32 over 16. I have two intervals of 2. Then another one I consider.
Interval up to it will take long, right?
Exactly, yes, sir.
It is up to you. You can take interval of 2, you can take interval of 4, you can take interval of 8. It is up to you. But if you want to get the exact some insight from the data set, what is preferred? Preferred is this is the one which is going to be preferred. Otherwise, 2 is very low, 8 is very high, right?
Yes.
Yes.
Okay, so what if for that one, I choose 5?
If you are choosing 5, you may not get this exact value. You have to approximate it.
Yeah, okay, I get it now.
5, 6 point something. So 6 point something, you should always try to get the whole number so that at least you can divide into the intervals.
Yes,
Otherwise,
sir.
if you are taking 5, 5, 6, 3, 6 point 4, is not a divisible,
Okay.
right?
I want to get
So
something
you
clear.
should choose one should choose an interval that will give whole number as the answer at
Yes,
the end of the day.
yes,
Okay.
and it should not be very less, it should not be very high, right?
Very high.
At
Yes,
least you
exactly.
should.
Doc, I want
Okay.
you to clear me of something. There's a question one of us asked about the N. So what I did was, after I did 45 minus 13, I got 32. Then I counted the variables. I counted the elements in the order. I got 16. So I used 16 as my N, like we did in the previous one. I used 16 as N to divide. I now got 2. So reducing it, what is the criteria one can use in deciding to reduce the interval? Because 2 will be much.
Yeah,
So
2 is
what
the
can I apply? What formula or idea can I use to apply?
no,
To be able
idea is only one idea. Look at here. You have counted high minus low. High minus low, as you see, I counted 32. And what are the fraction of 32? Multiple of 32 are 2, 4, 8, 16. Am I right?
Yes, sir.
Yes, sir. Yes, sir. Yes, sir.
We are not going to count them individually, because once your data set is small, you can count. What of million and trillion data set? You cannot count. You have to devise some algorithm, right? Yeah.
Exactly.
A
Yes, sir.
small number you can go and count them, but as I told you that data set is small, it is workable by human being. But if its data set is very big, it is not workable by human being, my friend. So you see what is happening. I divided 32, and then it's multiple are 2, 4, 8. So I choose it so that it can take 4, 4 interval. So once it is taking 4, 4 interval, at least you have total number as 16. So 4 in how many? 2, 2, 4, 2. You see here 4, then again 4, again 4, again 4. At least something you can take into 4 to 5 intervals, right? So you can get the data inside. Actually, even, and if you are taking 4, it will be like, if you are taking 4, it is 8. Entire data set will come only into 2.5 intervals. So you are not going to gain insight about the data set. You cannot know this actually, that where is the outlier, which one is in high range. And that's why this is not very relevant discretization. You see, it is already written that This is most relevant, most preferred, right? Equal depth is the preferred, equal height is not preferred, because problem with N, capital N, and this ranges is also one of the problems. But equal height is always preferred. Clear?
Yes, it's
Yes,
clear
sir.
now.
Yes, sir.
So then if I choose the interval of 8, that means I can count 13 to 21, then 21 to 28, right?
Yes, you see, if you are interval of 8, you start from 31 to 21. Am I right?
Yes, I now close again.
Close again, then 22,
21 to 28.
21 to 20,
8.
21 to 28, only this.
Then 29 to 36.
29 to 36 will be this, right?
Yes, so I will now have 37 to 45.
So 4 intervals, right?
Yes, yes.
So if you choose 4, you will get more intervals.
So that one, is it the EW binning?
Yeah, that is EW winning.
Okay, so
Equal depth, equal depth, you will always get equal depth. Height will remain. This, its width is changing, but height remain the same. It's very easy. I don't know why you people are just like struggling in this. It is very easy.
No, no, sir. So
Prof,
we got
we'll get
it now.
it.
We got it,
We
and
got it now. Yes, we got
It's
it
clear,
now.
it's clear now. So
I'll
equal
be
width
having network. I'm not clear, please.
You can watch the video if it is not clear. Network is another problem, but it is very simple thing actually. You can rewatch the video. I know that you will understand it.
okay, sir.
Anybody?
And again, sir, in this ED, we can see that both numbers are included. They are closed. Unlike the other one,
Yes. This is closed
open-ended.
interval. This is closed. But you remember, once you close here 69, so you are not taking 69 again.
Again, yes, sir.
So this is different
Okay.
in ED and EW. EW was right open. ED is not open.
Yes, sir.
Can I teach you one more method, class? Allow me to go ahead so that I can tell you one more method.
Go ahead, sir.
Yes, go ahead.
Okay.
Sorry, please, doctor. Like the one we just solved now. We pick. You looked at the multiples of 32, right?
Yes.
And then I can choose to pick 4. Somebody else can choose to pick 8. Is it?
Yeah,
Is that
no
what you're saying?
problem. No problem.
Okay, then in this case, which one did we pick? Is it 4?
Huh?
Or did we now pick as our n?
It is up to you. You can choose 8, you can choose 4 in EW, right? And in ED, you are free to choose 4, you can choose 3, you can choose 4, because last one is exempted, right?
Mm.
So in ED, this equal depth is convenient actually. You can decide depth of 3. So if you just decide depth of 3, 13 to 16 will be 1. You see here, another problem. If you are deciding depth of 3, you start from 13 and 16. You cannot manage in 3. Am I right, class?
Yes.
That's
Yes,
13
sir.
to what?
Huh?
13 to what
13
for
to
depth of 3?
16 if we are deciding on 3.
Then 16 will be going in 2 places. It is closed.
Yes.
So you have to take 4 minimum. If you are taking 4, 13 to 16 will be 1. And then 17 to 22. Look at here again is another problem. Are you getting the problem, class?
Yes, 19 to 22.
No, not 19. It will be 17.
Oh,
It is
17.
continuous.
Yes.
Yeah. It is
Yes,
17
17.
to 22. So 22, this 22 will be out, right? So,
Yes, sir.
so that means even 3 is not working, 4 is failing, 2 are failing. So this, are you getting my problem?
Yes.
Yes, yes, sir.
So this failed, this failed. Let's talk about 5. So 13 to 19, 13 to 19, one thing, clear?
Mhm. Yes, sir.
Yes,
Then 22,
20
20, 22, 25, right?
Yes, sir.
Yes.
Then 26 to 36, right?
Yes, sir.
So then 37 to rest. Here equal height will be 5, if I am not wrong, right?
Mhm.
Class, is it clear now?
Yes, equal height will be 5.
Yeah. 4 is having issue. If you start with 4, this is okay, but this is not okay, because you know here it is inclusive. It is like closed. 69 you have to here, and then 70 to 72. It is closed bracket, right?
Okay.
Yes, yes, sir.
So don't take equal height as 3, don't take equal height as 4. Take equal height as 5.
5. Yes.
Allow me to go ahead if you are done with this.
Yes, go ahead.
Okay. So next one is data cleaning, right? So everybody know that you have seen like data birth to like date age 222 years. So like it's not like something is convenient that a person can live up to 222 years, right? So this kind of things should not be in the data set, or somebody's salary is like negative. This kind of data need to be cleaned before going ahead, right? Yeah. So this data cleaning is a routine attempts to fill in missing values, smooth out noise while identifying outlier and correct inconsistency, right? Yeah. So what are the major steps in data cleaning? Many tuple no recorded value for space several attributes such as customer income is not there. How can you go about filling the missing value for this attribute, right? What will happen? You might have seen that sometime you have written the examination and your booklet is missing. Huh? Out of, let's say, it is happening that out of, let's say, 100 students appeared for the examination, and suppose by the mistake of the lecturer, 1 or 2 examination booklet has missed. So what will happen? Can you tell me the solution if 1 or 2 booklet has missed? Class, how to handle this kind of situation? Suppose 100 students wrote for the examination and 1 or 2 students booklet is missing, and you can't find the booklet. What is solution? How to award the grade? Are you going to conduct examination again for the student?
Yes, conducting another examination should be the preferred option at that stage.
No, but the student can claim and go to the court that he has written the examination. How can you miss the booklet for exam student? Suppose I am taking machine learning examination, and you wrote
Yes.
examination, you have proof that you have signed the examination hall, everything, and I missed the booklet. It is not your mistake, it is my mistake. So you can
Yes.
claim that how can I write exam again? You might have forgotten everything after 3 months. Right?
It's a
That your
big issue.
solution. That's your solution. Is student will go to the court, and you may lose the case. So it's
Yes.
not a solution, right?
Yes.
Okay. Okay.
Somebody else can anybody can propose the solution which everybody is okay.
So I think that it has to be established first that from the attendance that student wrote the exam, then the lecturer has to provide the booklet, the answer booklet.
No, lecturer has lost the booklet already. Then what else is the solution? He has lost the booklet. You know, while he was going on KK, he missed the booklet. One or two booklet are coming from the examination hall to the office. Somebody might have stolen the booklet from his office. Something might have done it that he has no access to booklet. It is given now. So if somebody is asking you the solution, what will be the solution?
That- It's a very complex issue.
It's not a complex issue. It's very easy issue. I'm dealing every year. This kind of
Okay.
issue I used to deal every year.
Okay, Prof.
I felt
You know you have one lecturer in Uni Abuja, Malam Abdumosi.
Mala Abdul Musi.
You know him?
yes.
I don't know him.
Huh? Some of you are working with Uni Abuja already, like Nonso is working in the Uni Abuja.
Yes, but I maybe from the name, I might know him in person, but I don't know.
He is your examination controller. He is examination officer.
Okay, Malam who again?
Abdumosi.
Ah,
Okay, no
So is-
problem. No problem. Leave him. Let me propose you the solution. You know what is solution? Class.
so
Okay.
tell us, sir.
You know, we used to find out the solution in many ways. Like you see, 100 student wrote the exam, right? No problem.
Yeah.
100 student wrote the exam. 2 booklets are missing. So what we are taking? We are taking average of all these 98 student marks, right? Class.
Yes.
Yes.
We are taking mean of 98 student if the mean of the class scores, right? If you take mean of the score of these 98 student, you will find out that okay, most of the student are falling in this, and we used to award the mean score to that students, so they will be happy that yes, they have not failed the course, and they will even not go ahead, because you just take average of 98 student, whatever average is coming, award to that these 2 students. This is one solution, right?
Okay.
Okay.
This is what we are doing. We are taking that, we are just checking that okay, what are the grades, generally which side grades are falling, not many failing, not many high side, so we will take the average. You know, if variance is not too much, we will take the average of the marks. After taking the average, we will award these marks to the students. This is number 1. What
Okay.
is number 2? Number 2 is even better. We will check other grades of these 2 students, grade in other subject, right? So once you
Okay.
check the grade in other subject of these 2 students, find out how they have performed in all other subjects. Suppose
Okay.
student is writing 6 courses, and out of 6 courses, you can see that only 1 course booklet is missing. In 5 courses, if he has done A in all the courses, so definitely, if you are going to award him in C grade or B grade in other subject, he will claim he want to see the booklet, right? And
Yes.
then you will be in a trouble because you don't have his booklet.
Hmm.
So, you
Yes,
know,
sir.
looking at his other grades, so if lecturer is awarding seriously, let's say, if you don't want to give him A grade, you can give him like, let's say, 65 marks, be close to B grade. And then you can say that, oh, you are lagging with 5 marks. So that's why you are not getting A grade. So he will be satisfied. He will not want to see the booklet. But if you are giving him C grade, definitely he will insist that he want to see the booklet, because he is very confident that he has done the course very well, right?
Exactly,
Yes.
sir.
So these 2 methods are always helping to save yourself. I will tell you one student's problem when I was working with Yobe State University. She got all A in 6 courses, right? 6 courses she secured A, everywhere A. But there is one course GST in Nigeria, General Studies, where 600 students, 700 students of public university, they are writing examination. In science, they wrote, so I don't know what has happened to her. She got B grade in that course, in GST. She was not able to get 5.0 in first semester because of that GST examination. On the other hand, one student got 5.0 because she got A in GST also. So I ask a student to go and meet the lecturer and see the booklet that where she got B grade. She went there, she couldn't find the booklet, blah, blah, blah. You know, public university, they will say that, no, I will show you another day. Something they have just bypassed. She just seem forgotten about that grade. So this is happening when you have many booklets and the results may be like not very accurate. Are you getting my point?
Yes.
Yes, sir.
Yes.
Yes, sir.
So this is how we used to. We are sometimes taking mean, but you know, mean is only preferred option when your grades are not fluctuating, right? Suppose one student is getting 0 marks and other is 99 marks, right? And you have only 3 students, and if you are taking its average, you cannot award 50 marks to the middle student because grades are variation is very high. So you know, sometimes we are calculating the variance of the grade also, that if there is no much variation, you can award the average. If there is variation, don't award the average. Then go and find out another method of checking his another grade. So this is the way of feeling in missing the value. Look at here. If you want to miss the value, ignore the tuple. It is not possible. Fill in the missing value manually. Is not even possible. Use a global constant to fill in the missing value like unknown 999, or use the attribute mean to fill the missing value. Sometimes it is also not possible. Or use the most probable value to fill in the missing value. So many methods are there to fill the missing value. But let me tell you, none of them they are correct. Why? Because you know, you cannot say that this is 100% correct, right? But it will give you only accuracy. Suppose you know, if somebody has not provided his income in the database, what will happen? If he has not provided income in the database and you are randomly putting the income, it is not going to be correct. Am I right, class?
Yes.
Yes, sir. Yes, sir.
Yes, sir.
Yes, go ahead. You want to ask question, class? No.
No.
We are responding to your.
Okay. So you know, data cleaning is also very helpful in noisy data. Noise is a random error or variance in the measured variable. So given a numerical attribute such as say price, how can we smooth out the data to remove the noise? So you know, this removing of the noise is also done by the smoothing technique, right? Smoothing technique. Look at here. So you know, this data is cleaning is smoothie like noise, especially like this petrol prices and other things. You need to smooth out the noise. Look at here. So smooth data cleaning noisy data. First again binning is coming here. You know, you did EWED binning. Again this is binning here. So what will happen? Let's see. Sorted data for price in dollar 4, 8, 15, 21. This data set is like noisy data, and you cannot be working with the noisy data. So what will happen? Partition them into equal bins. How many of them? They are like 9. So let's partition them into 3 bins. Bin 1, bin 2 and bin 3. Clear, class? 4, 8, 15 is one bin. 21, 21, 24 another bin. 25, 28, 34 is third bin. Clear?
Yes, sir.
Okay. So you know, smoothing after partitioning into bins, you have smoothing by bin means. So what is bin means? Smoothing by bin means will be what? You know, if you take mean of this bin, so mean of this bin is 23 plus 4, 27, divide by 3 is 9, right? Same thing is smoothing by bin mean is 22. And what is its bin mean? Its bin mean is 29. So smoothing means that if you have 9 as a average mean, replace every data by 9. Every data is being replaced by 9. Look at here, 9, 9, 9. Same thing bin 2, replace every data by bin means 22, 22, 22. Same thing here, replace every data by 29, 29, 29. So what is your entire data set which is being converted is 999, 22, 29, 22, 9, 29. Are you getting the point, class?
Yes.
You know,
Yes, Prof.
this is one way of smoothing out fluctuated data. You know, your data is noisy. So what you should do, use binning. So divide the data set into equal number of bins, right? Like your data set is 9. You know, you should not be taking the one bin size very big. You just take a small bin so that your data set should have not much variation. So you see, after taking this, divide this 27 average by 3, it is 9. So every data set will be replaced by this average. So 999. Same thing, every data set is replaced by 22. Every data set is replaced by 29. So what will be answer? Your entire data set is 999. This. So you know, this may introduce error. So what is error? How to calculate error? Error is modulus, mod of the variation from the actual value. Like here 9. 9 minus 4 is 5. This is the error. 9 minus 8 is 1. This is the error. 9 minus 15 is 6. This is the error. You take the modulus value. Don't take the negative value. This is error introduced in bin number 1. Same thing, 22 minus 21 is 1. 22 minus 21 is 1. Then 22 minus 24 is 2. This is the error introduced in second bin. Same thing, yeah, error introduced. You know, you take the modulus. 29 minus 25 is 4. 29 minus 28 is 1. And then 29 minus 34 is
34.
You know, you take the modulus, you just subtract and you see that error in this approximation is 26. I hope it is clear to everybody. Class.
Oh,
Yes, sir.
Very correct. And you will see that this bin means is not correct. Let's say bin median. Partition them into
network not
yes. Lucy.
Yes, I'm getting you. I only wanted to ask a question.
Yes, go ahead.
Okay, like, you know, we are having some negative values, which shows that that is the error, right?
No,
If after taking the mean, excuse me, after taking the mean, like the beam 1, we had the last one, 9 minus 15 is minus 6. We don't consider that negative.
No, you don't consider negative value. You take the modulus of the error.
All right, okay, the modulus, okay. That means, but why? How do we know that is the error? Is it because of the negative sign?
No. Error means that you know what you did. Try to understand what you did. You transformed this entire data set into this. How you transform? Because prices are fluctuating. Look at here, 4, 8, 15. Then all of a sudden 21, 21, 24. Then all of a sudden, so this is a noisy data, right? So you want to smooth out this entire data set. So divide them into small part, bins, and replace this entire data set like by bin means. So like this is 9. Right. Same thing is like 22. This is 29. So you are replacing individual data set by new values. And this error is the replacement of old data set by new value. So how much is error in this approximation?
Okay, understood. 26.
Yeah, you know error. And what is your objective? Tell me. What is your objective?
My object?
Objective is to minimize the error, right?
Yes, sir.
You don't want to take me. This 26 is very high error. We don't want it, right?
Yes, sir.
Let's have another method. You see, partition by bin median, right? This is bin median. So again, same thing is happening. What is median of this bin? 8. Median is 8. Replace every by 8. Everybody. What is median of this? Is 21. Replace them 21. What is median of? You know how to calculate median, right?
Yes.
Yes, sir.
28.
Even data, odd data is not a problem. I'm not going to teach you to calculate the median. It is your own part, right? So take the median and then approximate. You see, if you approximate here, if you go and approximate here, you know you will get error equal to 23. I'm not going to teach you how to get 23. Just subtract it and add them together. So this is better than 26, right?
Yes.
Yes, sir. Yes, sir.
Yes, sir.
So this is even not better. Mean, median, mod you can go on mod also, but mod is also, you know what is mod of this? 4, 8, 15, all the values are distinct. You can't get the mod, right?
Mode is the highest number there.
Mod is not the highest number, you know. Mod is always the number which is occurring mostly.
Yes.
Yes, the frequency, okay.
You have forgotten the mod calculation. You know, if data sets are distinct, there is no mod, right?
Yes, sir.
Class, you know, if you have the unique data set, so there is no mod of the data set. So that's why mod is failing here. So we don't want to work on mod, only mean and median. Yeah, like in 4, 8 and 15, you cannot get mod. 21,
Yes, sir.
21, 24, you can get mod equal to 21, but there is no
21.
mod in the third. Yeah.
Yes, sir.
Yeah, so okay. So but this is the most preferred. Most preferred is the bin boundaries. This is the most preferred method. Like see here, if you have 4, 8, 15, what are the bin boundaries class? This is the bin boundary, this is the bin boundary, right? This is the bin boundary, this is the bin boundary. So you are going to use both by bin boundary. So like see, bin here, bin boundary, 4 is definitely closer to 4, so 4 will remain 4. This 8 is not closer to 15 because difference is 7 and 8 and 4 has 4 difference. So definitely this class, look at here. This is your data set 4, 8, 15, partition like bin boundaries, how they are doing, you see, 4 remain 4, right? Both boundary values remain 4. 4 and 15 remain 4. Now this 8 is going to join 4 or 8 is going to join 15? Tell me. Hello class.
Yes, sir.
Hello, sir.
8 is going to join 4 or 8 is going to join 15?
4, sir.
Definitely, because it is very close to 4, right?
Yes, sir.
So that means this is going to join 4. Let's talk about second. 21. Yeah, but this 21 is not going to join 24, it is going to join 21. So this is 21, 24. Same thing here, 25 remains same. This 28 variation with 25 is 3, 28, 34 variation is 6. So this 28 is going to join 25. So this is 25. So this is your value. And if you get the error, you know error will be 7 here. Clear, class?
I don't understand,
So
sir.
this place is not a like we have the boundaries. How do we get these center ones like 8 and 28? The first one and the last one.
No, this is your data set. Original is the data set. 4, 8, 15 was the data set. Look at here.
Okay.
This is, you know, I'm coming from right to left. This is your data set. 4, 8, 15 is your original data set. Look at again.
Okay.
This is
Okay,
your
okay.
original data set. This is the check data set.
Okay.
So 4 and 15 remain the same, right? This 4 and 15 remain the same.
Yes, sir.
Question is that this 8 is going to join 4 or 8 is going to join 15?
It's 4, sir. I got it. You are moving from there to the left. That's the confusion.
No confusion. That's why I'm teaching you. No? I'm telling you that I'm coming from this to this, right?
Yes, sir.
This
Yes,
is your
understood.
original data set. This is your original data set, right? And this left is transformed. Then 21, 24 remain. This 21 is like what? Tell me. 21 minus 21 is 0. 24 minus 21 is 3. So definitely this guy will join 21. Same thing 28. Don't want to go with 34. 21, 8 will go with 25, right?
5.
Clear now?
Yes, sir. Yes, sir.
So you see, if you go to calculate error, you will see that error is in this approximation is the minimum, which is 7.
Okay.
Yeah. So this partition like smoothing by bin boundaries is the best method.
Okay, smoothing by bin boundary is the best method. Okay.
Yeah. You can note down this question. Note down this question. 2, 4, 6, 10. Class 2, 4, 6, 10, 12, 14, 16, 20, 22, 25, 30, 26, 31. Smooth them by bin means, median and boundaries. This is your homework. We can meet next time and we'll talk about this in detail, right?
Okay, so can we?
Okay, sir.
Can we take it down?
Your homework.
He said we should take it as homework.
Okay. Can you give us the question maybe on the chat so that we can copy it?
It is already here. You can't see it.
This one that is showing here now, 2, 4, 6, 10, 12, 14, 16, 20, and 22, 25, 26, 31.
That we should smooth by
All
mode.
three methods. It's smooth by all three methods. By bin, mean, median, and boundaries.
Bin, median, mode, and boundaries.
Not mode, just take mean, median, and boundary.
Okay.
Take
Okay,
home.
bro.
Yeah, you can take home. This is very simple method. You can, and after approximating, don't forget to calculate the error, right?
Okay.
Yes, sir.
And
Yes,
you will
sir.
notice that error is always minimum in bin boundaries. Generally,
Yes,
this data set, if it is a lot of fluctuation, we use to smooth by bin boundaries. It is the best preferred method of data smoothing.
Yes, sir.
You can take it as a home, take home. Next time we can meet and then we'll discuss more methods.
Okay, sir.
Okay, sir. Thank you very much, sir.
Can we close for the
Thank
day?
you, sir.
Yes.
Thank you, sir.
Thank you. Thank
Okay.
you very
Go.
much.
Please
had
try to
serious-
join
Hello,
on
sir.
time.
Hello,
Yes.
hello, sir. I
Yes.
had serious network issues. I have been off and on. I didn't follow the last lecture, but I think maybe I'll be able to use your recording.
Just
You
watch
can
the
use the video.
recording. My side recording is good.